Good evening, students. Welcome back. Today, we are diving into a very fundamental but extremely important concept in data analytics: data types and formats. Why does this matter? Well, think about it. If I give you numbers like 85, 90, 75, you can quickly calculate an average. But if I give you words like good, excellent, poor, you will analyze them differently. That's the power of data types. So in part 3, we will begin with data types and formats, different data types, quantitative versus qualitative, common data formats, CSV, Excel, SQL, databases, etc. In this module, we will see introduction to data types, qualitative data and characteristics, quantitative data and characteristics, common data formats overview, spreadsheets format, database data formats, data format selection and best practices. Now, what is data types? Data types define the kind of values that can be stored and processed. They help in organizing information for meaningful analysis, provide rules on what operations can be performed on the data, ensure accuracy, consistency, and proper usage in computing or analysis. Understanding data types is the first step towards effective data handling. Now, importance of data types. Decision making. Data enables leader to make informed strategic decisions using facts, projections, and predictive analytics. This data-driven decision making is vital for organizational growth and competing in the market. Science and research. Data is at the core of scientific research and discovery. Researchers rely on data analysis to test hypotheses, derive insights, validate concepts, and make few findings. Data helps accelerate the pace of innovation. Technology and innovation. The tech industry relies on data to improve products, services, enhance user experiences, and develop data driven business models. Startups leverage data analytics to build descriptive solutions. Social good. Data helps governments, non-profits, and international agencies track progress on social issues, allocate resources, and design targeted interventions to uplift communities. Legal research. In law, data aids in examining prior cases, understanding crime trends, conducting forensic analysis, projecting future litigation patterns, and regulating new technologies. These are the important of data types. Now we will see categories of data types. What are the categories? These are the categories that is in front of you. Data types: quantitative and qualitative. Quantitative means numerical data, and qualitative means categorical data. It also categorizes into the two parts: discrete and continuous. Discrete, countable, example number or students. Continuous, measurement, height or weight. Qualitative category data, it also divides into the two: nominal and ordinal. Nominal means names, labels, example color, gender. Ordinal means ordered categories, example rankings, grades. Categories of data types. Qualitative data. Categorical data represents attributes, labels, or categories. Nominal data categories without any order or ranking. Used only for identifications or classifications. Example colors red, blue, green. Gender male, female. Blood group, etc. Ordinal data categories with a meaningful order or ranking. The intervals between rankings may not be equal. Example grades ABC, satisfaction level, high, medium, low, ranking in a competition. Quantitative data, that is numerical data, represents number or measurable quantities. Discrete data consists of whole numbers or countable values, cannot be divided meaningfully into smaller parts. That is example, number of students in a class, number of cars in a parking lot. Continuous data can take any value within a given range. Measurement and often involves decimals or fractions. Examples height, weight, temperature, time. These are the categories of the data types, different categories of the data types. Now, these are the comparison, basic comparison of the qualitative data and quantitative data. This is the basic comparison between qualitative data and quantitative data. Basic of comparison meaning qualitative. Qualitative data is a data in which the classification of objects is based on attributes and properties, whereas quantitative data is the type of data which can be measured and expressed numerically. Research methodology in qualitative data, exploratory; in quantitative data, conclusive. Approach, subjective; on the other hand, objective. Analysis, non-statistical; on the other hand, statistical. Collection of data, unstructured; on the other hand, structured. Determines depth of understanding in qualitative data. In quantitative data, level of occurrence. Sample, small number of non-representative samples. On the other hand, large number of representative samples. Outcome, develop initial understanding. On the other hand, in quantitative data, recommends final course of action. I missed one point. Ask, that is why. In qualitative data, why it is asked. In quantitative data, how many or how much. Now we will see what is qualitative data. This type of data is about categories, labels and descriptions. It answers questions like why and or how. We divide into two subtypes. Nominal data, that is categories without order like blood group, gender, colors. Ordinal data like categories with order like grades ABC or survey rating satisfied, neutral, unsatisfied. Now take an example. Imagine we run a survey asking students their satisfaction with cafeteria food. Options are excellent, good, average, poor. That's ordinal data. If we just ask their favorite food, Indian, Italic, Chinese, that's nominal data. Now, what are the methods of collecting of this qualitative data? Interviews, focus groups, observations, case studies. Qualitative data is rich and deep but also messy, hard to organize, time consuming, and subjective. And what are the importance of this qualitative data? Qualitative data helps in understanding human experiences, behaviors, and social dynamics, enhances the depth and richness of research, supports better decision making with contextual insights, provides nuanced assessment of business, that is, customer sentiment, brand satisfaction. The characteristics of this qualitative data are non-numerical nature, represented through words, images, or descriptions instead of numbers. It explains why and how, reveals reasons, emotions, and experience behind data. In-depth insights captures detailed responses, personal stories, and sentiments. Challenging to organize, requires coding and thematic analysis to identify patterns. Why to use this qualitative data? Determine frequency, identify traits, characteristics via interviews or observations, form parameters, define categories to support quantitative studies, identify patterns, reveal themes, trends, and hidden relationships, explore depth, capture motives, context, and cultural influences. Now, I already told what are the methods for collection, qualitative data collection methods. That is interviews. One of the most commonly used method can be structured, semi-structured, or unstructured. Focus groups allow researchers to investigate different viewpoints and directions among participants on the specified topic. Observations capture real-time behavior and context to gain a first-hand understanding of the subject without depending on participant self-reports. Can reveal subtitles other approaches may miss. Open-ended surveys and questionnaires let respondents freely express themselves outside the bounds of a face-to-face interview. The best approach is to identify whether the answers are positive, neutral, or negative. These are the ways of collection of these are the methods of collection of qualitative data. Case studies. The holistic approach lets researchers look at different aspects of an individual or group to create a through and context rich grasp of an issue. Case studies are ideal for developing deeply into difficult and unusual circumstances, providing insights that may be used to inform more general ideas. Text analysis. This involves the methodological analysis of written or textual material, such as documents, literature, or web content, can show patterns, themes, and discoveries in written material, offering useful information on language usage and communication. Audio and video recordings. Audio and video recordings allow researchers to capture verbal, tone, and context clue. These recordings enhance qualitative data by capturing the intricacies of human interaction and behavior. So these are the methods of collection of qualitative data which we have seen right now. Now there's an advantages of qualitative data. What are they? It provides in-depth insights into human behavior, emotions, and experiences. It also explains the why and how behind trends and statistics, captures rich details through interviews, observations, and case studies, useful for exploring new ideas and generating hypotheses. It also offers context and meaning that numbers alone can't show. The disadvantages of qualitative data are time consuming to collect and analyze, subjective. Interpretation may vary by researcher, harder to generalize findings to larger population, difficult to organize due to open-ended and diverse responses, requires specialized skills that is coding, thematic analysis. Now we will see quantitative data. This is a numerical measurement objective. It answers what, how many, how often. There are two types of this quantitative data: discrete data and continuous data. Discrete data, countable values. Example, number of students in the class. Continuous data, measurable values that can take decimals like height, weight, or time. Now let's see example. If I say the temperature today is 32.5 degrees Celsius, then that is a continuous. If I say we have 50 students enrolled, that is discrete. Now the analyze techniques for this quantitative data are descriptive stats, regression, time series, ANOVA, cluster analysis. Quantitative data is powerful, but it misses the why. It can oversimplify human behavior. The importance of this quantitative data are provides measurable and objective results, enables statistical analysis and prediction, supports evidence-based decision making, allows for comparisons and benchmarking. It also helps in identifying trends and patterns at scale. The characteristics of this quantitative data are numerical in nature, counts, percentage, scores, collected through structured methods, surveys or experiments, easily comparable and replicable. Focus on what, how many, or how often. Objective and standardized for analysis. Why we use this quantitative data? When you need a measure variable prescriptively for large scale studies requiring generalization to test hypotheses with statistical methods. When looking for case and when looking for a cause and effect relationships for performance tracking and monitoring over time. These are the why to use this quantitative data. These are the points why to use it. Now steps for quantitative data analysis. Data collection. Gather numerical data from surveys, experiments, sensor or databases. Data cleaning and preparation. Handle missing values, remove outliers, and structure data for analysis. Exploratory data analysis (EDA). Use visualization and statistical tools to identify patterns and trends. Modeling and prediction. Applying regression, machine learning, or forecasting techniques to predict outcomes. Interpretation and reporting. Present findings with visualizations and reports providing actionable insights. What are the methods of techniques quantitative data analysis are? These are the method of techniques. Method and techniques. Descriptive analysis, cross tabulation, cohort analysis, factor analysis, cluster analysis. Sorry. Hypothesis testing and inferential statistics, regression analysis, ANOVA, Monte Carlo simulation, time series analysis. These are the methods and techniques of quantitative data analysis. These are the explanation of their techniques also. Descriptive analysis summarizes data using mean, median, mode, dispersion, and visualizations. Hypothesis testing and inferential statistical test relationships and generalize findings to populations. Cross tabulations examines the relationships between categorical variables using contingency tables. Regression analysis explores and predicts relationships between dependent and independent variables. Coherent analysis tracks groups over time to study behavior, patterns, and trends. ANOVA compares group means to identify significant differences. Factor analysis identifies hidden factors that explain relationships among variables. Monte Carlo simulation uses random sampling to model uncertainty and assess risk. Cluster analysis groups data into clusters based on similarities. Time series analysis analyzes sequential data to detect trends, cycles, and forecast outcomes. These are the explanation of methods and techniques of quantitative data analysis. Now the advantages of quantitative data. It provides objective, measurable, and reliable results. It also allows for statistical analysis making findings gen- generalizable. It also enables identification of patterns, trends, and correlations. It facilitates prediction and modeling of future outcomes, efficient for analyzing large datasets in less time. Now, the disadvantages of this of quantitative data are lacks depth in understanding human experience and emotions, may oversimplify complex issues by reducing them to numbers, requires careful design to avoid biased or misleading results, limited flexibility, focuses on what rather than why or how, can be resource intensive in terms of data collection and analysis. Now, introduction to data formats. What is a data format? Let's see how they are stored. That is where data formats come in. Data formats are like languages. They tell systems how to store, read, and share data. Choosing the wrong format can make analyze harder. Think about WhatsApp, text messages, photos, voice notes, all stored in different formats. Imagine if everything were stored in a giant Word file, would that work? No. So the data format plays a very important role. The data format refers to the structured way in which data is stored, organized, and represented so that it can be efficiently processed, analyzed, and shared. They act as a common language between systems, applications, and users, ensuring that information is interpretable and usable. Different fields and tools use specific formats depending on data type, that is text, numbers, multimedia, etc. Purpose and compatibility needs. Choosing the right data format is important for data quality, storage efficiency, portability, and analysis. Data formats can be human readable, easy for people to understand, example CSV, JSON, or machine oriented, optimized for performance, example Perquet Avro. Why data formats matter? Now, before why data formats matter, let's do an interactive activity. Suppose you want to find all students who scored above 90 in data analytics. The SQL query would look like this. Select name marks from students where marks is greater than 90. Even if you don't know SQL, can you see how easy that is to read? Who wants to try modifying it to find students with marks less than 40? That is your homework. Try it. Now, why data formats matter? It enables data exchange between systems, affect storage size and processing speed, ensure consistency and accuracy in data handling, support integration with analytical tools, databases, and applications. These are the common data formats, that is CSV, that we all know the CSV files, Excel, SQL, JSON, XML. YML. These are the common data formats. Role of data formats in data storage and exchange. What are the role of data format in data storage and exchange? Efficient storage. It organizes data compactly to save space. It also enables quick retrievable and processing. Data consistency. Standardized formats prevent misinterpretation, misinterpretation, ensure integrity across systems, interoperability. It facilitates seamless data sharing between tools, applications, and platforms. It also supports both human readable CSV, JSON, and machine oriented Perquet Avro use cases. Scalability and performance. Optimize formats, example, color formats like Perquet. Improve query performance on big datasets. Probability, big datasets. Portability, make data easily transferable across databases, softwares, and devices. Now the text-based formats. XML, that is extensible markup language, is a markup language that defines a set of rules for encoding hierarchically organized documents. The XML language is classified as extensible because it also defining the markup elements. The key structure of XML are: XML is extensible. It allows you to create your own self-descriptive tags or languages that suits your application. XML carries the data, does not present it. It allows you to store the data irrespective of how it will be represented. XML is a public standard. XML was developed by an organization called the World Wide Web Consortium W3C and is available as an open standard. This is the example of text-based formats. Please write this code. This is an XML example. So students, please write this code for the XML example. Sorry. Written students. Now moving forward. How XML used in big data analytics? In big data analytics, XML plays a crucial role in simplifying data integration and improving data quality. With XML, organizations can standardize their data across different systems, making it easier to combine data from different sources. This enhances the accuracy of data analysis as it creates a uniform data format that can be easily analyzed. XML also helps to improve the efficiency of data processing and analysis. Since XML data is self-describing, it eliminates the need for manual data mapping and transformation. This also reduces the risk of errors and inconsistencies in data analysis. Now, use case of XML in big data analytics. There are several use cases where XML is used in big data analytics. Let's explore a few of them. Data integration. With XML, organizations can integrate data from different sources into a single format, making it easier to process and analyze. For example, a retail store may use XML to combine their customer data from different channels, such as e-commerce and brick and mortar stores, to gain a complete view of customer behavior. Data standardization. XML helps organizations to standardize data across different systems and applications. It enables organizations to create a shared taxonomy that covers all aspects of their business, from products to customers and transactions. Data transformation. XML can also be used to transform data into desired format, making it easier to process and analyze. For example, a healthcare provider may use XML to transform their patient records into a standardized format, enabling doctors to make informed decisions about patient health. Now, CSV, text-based formats. The full form of CSV is comma separated values. Comma separated value is a simple yet powerful file format to store and exchange data. Values are separated using commas in this plain text file format. CSV files are often used to store data in a tabular format, such as spreadsheets or database. These files are easy to create and edit and are compatible with a wide variety of software applications and are easy to share and transfer. Now, how CSV files work. Here is how a CSV file organizes data. Each line is one record. Commas or other separators divide the information in each line. The first line often describes what each piece of information is. The lines after that contain the actual data. This simple setup allows CSV files to show tables of information in a way that's easy for both people and computers to understand. Now the characters of CSV files. Its simplicity. CSV files are human readable and easy to understand, making data easy to debug and examine at a glance. Lightweight. Being plain text files, they have smaller file size compared to XML or JSON files that contain metadata alongside the actual data. Lack of standardization. While the concept of CSV files is simple, there are no universally accepted standards for their creation, which can lead to inconsistencies in format across different systems. Now we will take the example of CSV example. In the box, you will see some text is written: name, age, city, John 25, New York, Sarah 30, Los Angeles, Mike 28. Chicago. In this example, we have three rows of data. The first row usually tells us what each column means. Then each row after that has the actual information with commas between each piece. Now we will see how CSV helps in data analytics. Data import or export. Easily move data between tools. Excel, Python, R, SQL. Data cleaning. Raw CSVs often serve as input for pre-processing. Exploratory analysis. Analysts load CSV to explore patterns and trends. Data sharing. Common format for exchanging datasets across teams and platforms. Compatibility. Supported by almost all analytics and visualization tools. Now how to use cases for CSV files. Use cases for CSV files. CSV files find applications across many domains. Here are some notable examples are as follows. Data import or export. Most spreadsheet software, database systems, and business intelligence tools allow for exporting and importing data in CSV format. This is common in facilitating that migration, especially when moving data from one system to another. Data sharing. Due to the simplicity of CSV files, they are often used to share datasets among colleagues, especially in collaborative environments like research or business. Web development. Many developers use CSV for storing configuration data or for simple database in smaller projects because of the speed and ease of manipulation. Data analysis. Researchers and analysts utilize CSV files to gather, clean, and analyze data. Many data visualization tools support CSV formats for ingression, allowing analysts to create insightful visualizations quickly. Machine learning datasets. CSV can serve as input files or machine learning algorithms, simplifying the data preparation process since many libraries accept CSV. Now JSON, text-based formats. JSON, the full form of JSON is JavaScript Object Notation, is a lightweight text-based format for storing and exchanging data. It is easy to read, write, and widely used for communication between a server and a client. Now its characteristics are JSON stores data in key value pairs. It is language independent but derived from JavaScript syntax. JSON data is written in a human readable format. It supports objects like this brackets and arrays like in this brackets for data representation. Now this is the example of JSON. You can write or you can take the snapshot of this. Now moving forward, how JSON helps in data analytics, data exchange, widely used for APIs, web services send, receive data in JSON. Flexibility can store complex nested data, example user profiles logs. Interoperability works across languages, Python, R, Java, etc. Lightweight, smaller than XML, faster data transfer. Easy parsing, most analytic tools, pandas in Python, Power BI, etc., can directly read JSON. Unstructured data handling, suitable for NoSQL databases, example MongoDB. These are the how JSON helps in the data analytics. Now the use case of JSON. Web APIs. It exchanges data between server and client. Configuration files. It stores app setting and preferences. Data storage. It used in databases and NoSQL stores. Serialization and deserialization. Convert data structures to from JSON. Logging and monitoring. Record events and metrics in a structured format. Data interchange. Share data between apps and systems. Client server communication. Send structured data in web apps. Infrastructure config defines setup in tools like Ansible, Terraform. Mobile apps exchange data via REST APIs. IoT devices exchange structured sensor data. NoSQL databases core format in MongoDB, CouchDB, etc. Web development define routes and app configurations. These are the use case of JSON. Now the spreadsheet based formats. What are the spreadsheets? Excel, one of the powerful spreadsheet for program for managing large data sets, performing calculations and creating visualizations for data analysis. Developed and introduced by Microsoft in 1985, Excel is mostly used in analysis, data entry, accounting, and many more data driven tasks. Key features of MS Excel, Microsoft Excel. Here are the 5 key features of Excel every data analyst should know and use. Pivot tables are used to summarize large data sets to drive in meaningful information from them. As a data analyst, pivot tables will help you extract insights and identify trends easily without the need of writing complex formulas. Conditional formatting is used to highlight cells in Excel based on the specified criteria. You can apply colors, icons, or data bars based on conditions, making it easier to interrupt the results quickly. Using Power Query, one can import data from different sources, for example, databases, so as to clean and transform data from these sources without the need of hard coding. Data validation helps to restrict the type of data to be inputted in a cell. Print an error message in case the data entered is incorrect and create drop-down list to choose from. Lookup functions helped you to search for data in one table and return matching results from another. Lookup functions include HLOOKUP, XLOOKUP, index match, VLOOKUP. These are the features of MS Excel. Other spreadsheet formats, the ODS, Open Document Spreadsheet format is a part of the Open Document Format (ODF) family designed for storing spreadsheet data in an open, interoperable, and XML-based structure. It's widely used in tools like LibreOffice, Calc, Apache, OpenOffice, and even supported by Microsoft Excel and Google Sheets. The key features of these spreadsheets are open standard, ISO approved, not tied to one company, cross-platform, works on Linux, Windows, and Mac OS. Compatibility can be opened in Excel, Google Sheet, and other tools. Lightweight and flexible, based on XML, easy for software to process. Supports advanced spreadsheet features, formulas, charts, pivot tables, conditional formatting. Good for collaboration. Free to use, ideal in open source and educational setups. Other spreadsheets formats are Google Sheets is a web-based application that enables users to create, update, and modify spreadsheets and share the data online in a real time. Google Sheet is typically used for spreadsheet collaboration across different geographical locations. Multiple users can modify a Google Sheet document in a real time, with the exchange tracked for each individual user. The key features of Google other spreadsheet format are spreadsheet editing and formatting, data visualization and chart creation, cloud collaboration, Google product integration, Excel file compatibility. Database format. Now we will see the database formats. Structured Query Language (SQL) is a standard language used to interact with relational databases. It allows users to store, retrieve, update, and manage data efficiently through simple commands. It is known for its user-friendly syntax and powerful compatibilities. SQL is widely used across industries. How SQL works. In this box, in this picture, you will see how SQL works. Write a SQL query, send the message to the server, that is sent to server. Now the server send to the message to execute query, and after that the results return to the results. The results we see. This is the process of SQL works. Now we will see why should every data analyst learn SQL. Retrieval of specific data. Analysts often need to pull targeted information like last year's sales from databases like MySQL or PostgreSQL without loading extra data. Scalable with large datasets. Unlike Excel, SQL handles millions of rows and effortlessly, making it ideal for big data tasks. Data cleaning. SQL offers built-in functions to clean messy data, deal with missing values, remove duplicates, etc. Joining tables. SQL can combine related data from different tables via joins, something that's far more cumbersome in spreadsheet tools. Integration with visualization tools. Most BI platforms, example Power BI, Tableau, integrate directly with SQL databases, streamlining the analysis to reporting pipeline, facilitates collaboration. SQL is widely used across teams, data analysts, engineers, and scientists use it as a common language in data workflows. Now the conclusion, choosing the right data format. Key takeaways for data analyst. Alignment with data types. The choice of format should align with the data type, structured, semi-structured, or unstructured. Scalability and efficiency. Select formats that support efficient storage, retrieval, and scalability for large dataset. Interoperability ensures compatibility across tools, systems, and workflows to maximize analytical flexibility. Context-driven decisions. No one size fits all. Choose formats based on analytical goals, team expertise, and project context. Now, in this module, quickly we recap this module. We are starting from the data types, qualitative and quantitative, data formats, CSV, Excel, SQL, JSON, etc. Decision making, always match the format to your data and context. The big takeaway, choosing the right data type and format is the foundation of good analytics. Without it, even the best algorithms won't save you. Before we close, let's briefly recap the key points. Data types form the foundation of any analytics strategy. Quantitative data allows precise measurement and statistical testing, while qualitative data provides context, depth, and categorical differentiation. From there, the choice of data formats plays a pivotal role in shaping analytical efficiency. While SQL databases provide robust query and relational structure, JSON and other semi-structured formats offer flexibility, especially for modern APIs and web-driven data. Sorry. Every format involves trade-offs. Some are easier to use but less scalable, other powerful but more complex to manage. Recognizing these trade-offs is essential to building strong analytical workflows. Ultimately, understanding both types and formats equips analysts with the tools to extract reliable insights and to adapt methods to diverse contexts. So, this is all about the data types and formats. Different data types, quantitative versus qualitative, common data formats, CSV, Excel, SQL databases, etc. This module we have learned this data types. Now in the next module, part 4, we will see basic concepts of data visualization. Now we will see basic concepts of data visualization. The outline of this lecture in coming slides we will see introduction to data visualization, importance of data visualization, history and evaluation of data visualization, role of data visualization in analytics, basic visualization techniques, advanced visualization types, principles of good visualization, tools for data visualization, case studies, and also examples, challenges and limitations of data visualization. Now, what is a data visualization? What is the meaning of data visualization? Data visualization is the practice of representing data through visual means like charts, graphs, and maps. This process aims to highlight patterns, trends, and relationships within large datasets, thus making the information more accessible and much easier to understand, especially for those not to use working with data. Data visualization is particularly important in the era of big data, where amounts of information need to be analyzed and presented in a way that is intuitive for decision making. Again, the formally speaking, data visualization is the graphical representation of information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. Additionally, it provides an excellent way for employees or business owners to present data to non-technical audience without confusion. In the world of big data, data visualization tools and technologies are essential to analyze massive amount of information and make data-driven decisions. Now, why is data in visualization important? Data visualization is especially important nowadays, considering how much influence data has on so many industries. So these are the importance of the data visualization: enhanced data interpretation, improve decision making, communicates complex data effectively, identify trends and correlations, increases engagement and comprehension. These are the importance of data visualization. Now this is the real world applications of data visualization in business sector, healthcare sector, social media. These are the real world applications of data visualization. Business, sales dashboards, revenue by region, product performance, healthcare, patient monitoring, charts, heart rate, blood pressure, etc. Social media engagement metrics, likes, share, comments, trends. The business example are Amazon using visual dashboards to track sales and supply chain. Example of healthcare, WHO dashboards for global health statistics. And the example of social media is Twitter analytics visualizing trending hashtags. History and evaluation of data visualization. Now here you see the data visualization timeline and the history. Before 5500 BC and after 1786. 12,000 years ago, stellar data. The earliest form of data visualization was quite simple but very powerful. Early humans painted the positions of stars on the cave walls. 5500 BC. Clay tokens. As farming developed, people needed a way to keep track of commodities like grain and cattle. They use clay tokens to represent quantities. This way, this was one of the earliest ways of turning raw data into something we could see. 1160 BC. Terrain map. Here we have the first documented map drawn on papyrus to show geological resources. Imagine early Egyptians marking mining areas. This was visualization used to practical decision making. 1786 William Blair. Now we move to a big leap forward. William, a Scottish engineer, introduced charts, line charts, bar chart, and pie chart. He urged that charts communicate better than tables. This is the history of and evolution of data visualization. In 1869, Golden Age of Statistics. This famous chart by Charles Maynard shows Napoleon 1812 Russian campaign. It visualized the size of the army, geographical temperature and losses all in one chart. Here you can see the Golden Age of Statistics, 19th century. Then 1983, Sparklines by Edward Tuft. Edward Tuft introduced sparklines, tiny graphs that show trends in a small space. His book, like the visual display of quantitative information, is still a Bible for visualization students today. 1990, Microsoft Excel. Here's a tool many of you already know. Excel made visualization mainstream. Sorry. With just a click, we could turn rows and columns into bar graphs or line charts. Now the present day, modern visualization tools. Now we are in the era of dashboards and interactive visuals. Tools like Tableau, Power BI, and even Python libraries like Matplotlib and Seaborn allows us to create real-time dynamic charts. So we will see from cave paintings to AI-powered dashboards. Data visualization has always been about one thing: making sense of information and telling stories through visuals. Now the role of data visualization in analytics. Exploring of data helps in exploration of data, identifies patterns, trends and outliers, improved decision making, enhanced communication and storytelling, builds interactive dashboards for monitoring. Basic visualization techniques. Bar chart. Bar charts are used to compare values across different categories using rectangular bars. X-axis shows categories while y-axis represents values. In this you will see the bar chart that on the left bar values are given and on the right bar alphabets are given, that is ABCD. Categories are given. Common types include historical or horizontal, stacked and grouped bar charts. This when to use to compare different categories, to rank values from highest to lowest, to show relationships between multiple variables. Line charts. Line charts shows how values change over time by connecting data points with lines. They help visualize trends like increases, decreases, or stability. In front of you, the line chart is given. When to use to track changes over time, to compare trends across multiple data series for time series analysis. Pie chart. This is the pie chart. Pie charts are round charts divided into slices, where each slice shows a part of the whole. The size of each slice represents its percentage. When to use to show how different parts contribute to a whole. To highlight a dominant category. Scatter chart, that is plot. Scatter charts use dots to show relationship between two numerical variables. X-axis shows that independent variables and y-axis shows the dependent variable, as you can see in the picture. When to use to observe relationships between two variables, to detect patterns, clusters, or outliers in data. Histogram. Histogram displays the distribution of numerical data by grouping values into intervals, bins, and showing their frequency as bars. It helps reveal the shape, spread, and patterns in the data, as you can see in the picture. When to use to visualize the distribution of numerical data, to explore patterns, trends, and outliers. Heat map. I think you all knows or listen these terminologies which I am discussing right now. Heat map. A heat map displays data in the matrix format using color to represent values. It's ideal for spotting patterns, correlations, and variables in the large data sets, as you can see in the picture. When to use to identify clusters or grouping in data, to visualize correlations between variables, for risk analysis in fields like finance or network security. Area chart. An area chart shows trends over time by filling the space beneath a line. It's ideal for visualizing time series data and highlighting changes across periods. When to use to track changes or trends over time, to compare multiple data series, to highlight patterns like seasonality or cycles. Box plot, box and whisker plot. A box plot displays distribution of numerical data showing median, quartiles, and outliers. It's useful for understanding variability and detecting unusual values, as you can see in the picture. When to use to detect outliers in data, to compare distributions across groups, to visualize spread and variability. Bubble chart. These are the bubble. This is the bubble chart. A bubble chart displays data points as circles, where size and color of each bubble represent additional variables. It's useful for visualizing three or more dimensions in a single chart. When to use to compare multiple variables at once, to represent data using size and color, to visualize relationships and detect patterns. Tree map. A tree map visualizes hierarchical data using nested rectangles where the size of each represents a value. It's useful for showing structure and comparing proportions within a hierarchy, as you can see in the picture. When to use to display hierarchical data, to compare proportions within labels, to visualize large datasets compactly. Parallel coordinates. Parallel coordinates display multivariate data using lines that connect values across multiple axes. Each line represents a data point across several variables. When to use to analyze multiple variables at once, to visualize relationships or clusters, to detect outliers in the data. Path. A choropleth path map uses color shading to represent data across geographical areas. It's useful for showing differences like population density, income levels, or disease spread across regions, as you can see in the picture. When to use to compare data across locations to spot geographical patterns and trends. Sankey diagram. A Sankey diagram shows the flow of data or resources between points nodes using arrows where the width of each arrow represents the amount of flow. It's great for visualizing complex systems and spotting inefficiencies. When to use visualize flows, understand how resources move through a process. Find bottlenecks, identify points where flow slows or drops. Compare scenarios, track flow changes across time or conditions. Radar chart, spider chart. This is a radar chart. A radar chart displays multivariate data using axes from a central point, ideal for comparing variables across categories, common in the performance, analysis, sports, and decision making. When to use multi-criteria comparison, compare multiple variables at once, strengths and weakness, visual strong and weak areas, pattern recognition, spot similarities or differences between categories. Network graph. A network graph shows relationship between entities as nodes and links, edges. It helps visualize complex networks like social media, transport, routes, or biological systems. When to use relationship visualization helps shows connections or interactions between entities. Community detection useful to identify clusters or groups within a network. Path analysis shows shortest or most efficient routes between nodes. Donut or donut chart. The donut chart is a circular chart like a pie chart but with a hole in the center. Each slice shows a category's contribution to the whole, making visually clear and ideal for comparisons. When to use show pie to whole relationship like sales or market share, track progress towards a goal, example 70% completed, best when comparing a few categories. Gauge chart. A gauge chart shows progress towards a goal using a dial like arc similar to a speedometer. It is useful for tracking a single value like a KPI or project status. When to use to monitor key metrics, example sales satisfaction towards targets. in KPI dashboards to track progress for project status tracking against deadlines. Sunburst chart. It shows hierarchical data as nested rings. Each ring represents a level in the hierarchical, making it useful for visualizing multiple level data structures like categories, subcategories, or organizational hierarchies. When to use to visualize hierarchical structure like org chart or file system to explore proportions, and relationships within nested datasets to simplify complex data in a clean, interactive layout. Hexbin plot. It groups points into hexagonal bins and colors them by how many points fall in the each bin. It's useful for large datasets to show density clearly without overplotting. When to use to show data density in a 2D space to spot cluster or patterns in large scattered data to manage overlapping points in big datasets visually. Violent plot. A violent plot combines a box plot with a density plot to show distribution and summary statistics of data. It helps visualize that shape, spread, and center of the data across categories. When to use compare distribution of continuous data across groups, visualize data shape, spread, skewness, or multi-model patterns. Highlight detailed distribution and outliers in a clean layout. Now we will moving forward. Advanced visualization tools. Visualization charts or textual symbolic data. Word cloud. A word cloud visually displays word size by their frequency in a text. Common words appear larger. It helps quickly identify key terms or themes in text data. When to use to highlight key the themes or topics in large text data. To visualize word frequency in text analysis. To emphasize important terms in qualitative or sentiment analysis. Pictogram chart. It charts uses icons or symbols to visualize represent data. The number or size of icons reflects the value. It's helpful for showing qualitative or categorical data in a simple way. As you can see in the picture, fruit pictogram chart is shown in the picture. Apples, bananas, and cherries. When to use to present data using symbols, especially for non-numerical information. To communicate with audience of all literacy levels. To highlight key trends using clear recognition icons. Temporal and trend charts data visualization. Stream graph. A stream graph displays changes in data or over time using flowing stacked areas. It shows how different categories contribute to the whole across time. When to use to show trends and changes in category distribution over time. To compare the size of different groups over time. To highlight patterns in a smooth and visually appealing way. Bullet graph. A bullet graph is a variant of a bar chart, but it includes marker and references lines to show progress towards a goal. It's useful for tracking performance against a target. When to use show progress towards goals clearly and quickly. Compare actual performance with targets. communicate key matrices in dashboard or reports. Giant chart. A giant chart uses horizontal bars to show project tasks over time. It helps a planning, scheduling, and tracking progress visually. When to use plan and schedule tasks with dependencies, track progress and resource use over time, communicate timelines and milestones clearly. Waterfall chart. A waterfall chart shows how positive and negative values affect a total over time. It's useful for tracking changes in financial data, budget, or performance metrics. When to use, analyze step by step gains or losses over time. Understand the impact of different factors on totals. Present complex changes clearly and visually. Some of the principles of good visualization are as follows. Knows your audience. Understand who will viewing the data and tailor the visualization to their needs, expertise, and goals. Simplify technical details for non-experts while providing depth for data-savvy audiences. Choose the right type of visualization. Select the appropriate chart or graph based on the data and the message you want to convey. For example, use bar charts for comparisons and line charts for the trends over time. Keep it simple. Keep it simple. Avoid cluster and excessive details. Focus on the most important data and eliminate unnecessary elements that may distract viewers from the main message. Use color strategically. Colors should enhance readability, not overwhelm viewers. Use contrasting colors to differentiate between categories or highlight important data points and avoid over overusing colors. Provide context with labels. Always label access, include titles, and provide legends where necessary. This ensures that viewers can easily understand what the data represent without confusion. Use color strategically. Color should enhance readability, not overwhelm viewers. Use contrasting colors to differentiate between categories or highlight important data points and avoid overlooking colors. Provide context with labels. Always label access, include titles, and provide legends where necessary. These ensure that viewers can easily understand what the data represents without confusion. Maintain accuracy. Avoid distorting data with misleading scales or visual tricks. Make sure that the visualization accurately reflects the underlying data. This is the pictures of good principles of visualization. As you can see, the symmetry is seen in every picture. In cluster chart, clean chart, in correlation, see, you can see the symmetry in each of the charts. Tools for data visualization. Now, the what are the tools that we use for the data visualization? Tableau. Why it's popular? Interactive visualizations, seamless integration and multiple data resources. Great for business of all sizes. Power BI. I think you must know these all terms, Power BI, Tableau. These are the tools that are used in the data visualization. And these are the powerful tools. Why it's popular? Power BI, why it's popular? It's intuitive and accessible. Strong integration with Microsoft ecosystem. Customizable reports and dashboards. Quick View. This is also a tool. Why it's popular? Interface it's user friendly, stunning visualizations, trouble free maintenance. Plotly. Why it's popular? Complex datasets in a clean and engaging way, supports multiple programming languages, open source with great community support. These are the some tools for data visualization. Analytics, Zoho, Infograph, Spotify, Data Wrapper, Clipfolio. These are the tools for data visualization. You can take the snapshot for these names of the tools, and further you can apply in your data visualization methods. Now the case study. Example, blockchain technology world visualization. This visualization illustrates blockchain transactions, emphasizing the technology's inherent immutability. The interconnected blocks secured through cryptography showcase the ineluctable nature for recorded data. Maintain health user journey experience map. Focusing on mental health, this interactive map enables user to export the relationship between brain sections and specific symptoms. It provides variable information on system symptom development, varying signs, prevalences, and effective treatments. As you can see in the picture, mental health user experience map. In front of you, this is the mental health user experience map. Now, what are the challenges, limitations of data visualization? Now, the challenges and limitations of data visualization. There are some challenges in this data visualization. Misleading visualizations, lack of context, data accuracy and integrity, choosing visualization types, handling large data sets, real-time visualizations, challenges, communicating uncertainty, accessibility and inclusivity, data overload. These are the challenges in data visualization. The references are these. You can see the information, you can see the uh, links, you can see more about these topics through these links. You can take the snapshot. These are the links of information. These are the links of data stored in this links. यहाँ पे आपको सारी इंफॉर्मेशन मिल जाएगी जो हमने अभी तक इस मॉड्यूल में पढ़ा है. Now students, before we close it, let's wrap up the module, what we have learned today. The data visualization is a powerful but also responsible work. A good analyst is not just making pretty charts, they are making sure the message is true, clear, and useful. different visualization techniques. In this module we have seen the different visualization techniques, principle of good visualization, some popular tools, and the real challenges analysts face when working with visuals. So what's the big idea here? Data visualization is not just about making charts look nice. Remember, it's about telling a clear, accurate, and meaningful story with data. So I hope this module is clear to all. Once again, thank you. Any questions you may ask, you may ask, or any doubts. If you have any doubts, then you may ask right now. Okay, then thank you once again, and we will see some other module, the last module for this session, the last module. We will see tomorrow. Thank you all. Thank you, students.